What if everything around us, the stars, the planets, even the empty spaces between them, wasn't just random chaos, but part of a vast, breathing story? Picture the universe not as a cold, lifeless expanse, but as a living tapestry where every thread is a moment of discovery, a burst of starlight, or a whisper of ancient wisdom. For centuries, we've tried to unravel its mysteries with equations and telescopes, but what if the truth is woven from something deeper, something that dances between the precision of science and the magic of art? Think about the last time you looked up at the night sky. Those pinpricks of light aren't just distant suns, they're part of a pattern so intricate it mirrors the branching of neurons in your brain or the veins of a leaf. Scientists call these patterns fractals, nature's way of repeating itself across scales, but artists see them too, in the swirl of a painted galaxy, the rhythm of a symphony, even the flow of a story passed down through generations. Could it be that the universe isn't just out there, separate from us, but a living, evolving narrative we're all part of? From the myths of indigenous cultures who saw the cosmos as a great serpent or tree, to modern physicists uncovering the quantum threads that entangle particles across space, humanity has always sensed there's more to reality than meets the eye. This video is an invitation to explore that hidden layer where black holes hum like musical notes, where galaxies spin like brushstrokes on a canvas, and where the laws of physics might just be the grammar of a story still being written. By the time we're done, you might never see the universe or your place in it the same way again. So lean in. The tapestry is waiting. The universe hums like a loom, its shuttle weaving threads of light and gravity into patterns older than time itself. The Maya imagined the cosmos as a great weaving, their goddess Ixchel spinning the stars into being, while Hindu texts describe the divine dancer Shiva crafting reality with every movement, each step a vibration, each twirl a new galaxy. Even science whispers the same truth. String theory tells us the foundation of everything might be tiny, vibrating filaments, cosmic threads that hum in 11 dimensions. Physicist Brian Greene calls space-time a fabric, one that bends and ripples under the weight of planets and black holes. And in the early 1900s, artist Hilma af Klint painted swirling webs of color, her brushstrokes capturing what she called the unseen threads connecting all life. This isn't just poetry. When astronomers map the large-scale structure of the universe, they find a vast, delicate network of galaxies, filaments of light stretching billions of light years, intersecting like the warp and weft of some celestial cloth. Zoom in closer and you'll see the same pattern in the branching of trees, the flow of rivers, even the neural pathways in your brain. It's as if the universe has a favorite shape, a rhythm it can't help but repeat. So what if the loom isn't just a metaphor? What if it's the hidden grammar of existence? Every time a star explodes, scattering atoms that will one day become part of a planet or a person, it's adding a new stitch to the tapestry. Every thought you have, every choice you make, might be a tiny tug on the threads around you. Ancient myths and cutting-edge physics agree, nothing is truly separate. The air in your lungs once swirled in distant nebulae. The calcium in your bones was forged in the heart of a dying star. You're not just observing the cosmic loom, you're part of its design. Fractals are nature's secret handwriting, scribbled across the cosmos in shapes that echo endlessly from the branching of a lightning bolt to the spiral arms of a galaxy. Mathematician Benoit Mandelbrot was the first to give this phenomenon a name, showing how a single equation could generate infinite complexity. A coastline, when viewed from space or through a microscope, reveals the same rugged contours. A fern unfurls its leaves in miniature versions of itself, each frond a tiny replica of the whole. Even our lungs, with their intricate network of airways, mirror the fractal branching of river deltas. It's as if the universe has a favorite blueprint, one it uses again and again, from the infinitesimally small to the astronomically vast. Artists have long sensed this hidden order. Jackson Pollock's drip paintings, once dismissed as chaotic, were later found to contain precise fractal patterns, their splatters mathematically indistinguishable from the jagged edges of clouds or the uneven cracks in dried mud. The Dutch artist M.C. Escher played with recursion, drawing staircases that looped endlessly and fish that transformed seamlessly into birds, capturing the universe's love for repeating motifs. And in traditional Japanese woodblock prints, waves crest in fractal foams, their curves echoing the larger swell of the ocean. But here's the astonishing part: these patterns aren't just pretty coincidences. They're evidence of something deeper. When galaxies cluster along filaments in the cosmic web, they trace the same branching shapes as neurons firing in your brain. Physicists now study fractal geometry to understand everything from the distribution of matter in the universe to the way stock markets fluctuate. Even music, think of Bach's fugues, where a single melody folds back on itself in ever smaller variations, obeys this rhythm of repetition and scale. So what does it mean? If the universe speaks in fractals, is it trying to tell us something? Perhaps that chaos and order aren't opposites, but partners in an ancient dance. Or that the boundaries we see between art and science, micro and macro, are illusions. A single equation can describe the swirl of a seashell and the spin of a hurricane. A painter's brushstroke can mirror the path of a comet. Maybe fractals are the universe's way of reminding us, no matter how far we zoom in or out, we're always part of the same unfolding pattern. Imagine two particles born from the same moment, now separated by billions of miles. Change one, spin it clockwise, and the other instantly responds, spinning counter-clockwise as if whispering a secret across the void. Einstein famously rejected this idea, calling it spooky action at a distance, because it defied everything we knew about speed and separation. Light itself takes time to travel, but quantum entanglement suggests a connection that operates beyond time and space, as if the universe has its own hidden hotline. This isn't just a quirk of physics. Philosopher and physicist David Bohm saw entanglement as a clue to something far grander, what he called the implicate order. Picture the cosmos as a vast, folded origami. What we perceive as separate objects, stars, planets, people, are just the unfolded creases of a deeper, unified reality. In Bohm's vision, entanglement isn't an exception, it's the rule. Everything is already touching, already communicating, in ways our classical minds struggle to grasp. Centuries before Bohm, the poet Rumi wrote about an invisible thread connecting all things, tugging hearts across continents. Indigenous cultures spoke of the web of life, where every action ripples through the whole. Even modern neurobiology hints at this unity. When neurons fire in sync, separated by hemispheres of the brain, they behave eerily like entangled particles, instantaneous, inexplicably linked. So what if entanglement isn't just a laboratory curiosity, but a glimpse into the universe's true nature? What if the tapestry we've been exploring isn't woven from separate threads, but from a single, shimmering strand, folded and refolded into the illusion of many? When a star explodes on the far side of the galaxy, its light may take millennia to reach us, but could its quantum whispers already be here, humming in the spaces between atoms? Science is still unraveling the mystery, but one thing is clear: the universe speaks in a language far stranger and far more intimate than we ever imagined. In the 1970s, scientist James Lovelock proposed something radical: that Earth isn't just a rock we live on, but a vast, self-regulating system, almost like a living being. He called this the Gaia hypothesis, named after the ancient Greek goddess of Earth. At first, many dismissed it as poetic nonsense, but look closer. The planet maintains its temperature within a narrow range perfect for life, much like your body regulates its own heat. When carbon dioxide levels rise, forests grow faster to absorb the excess. When the sun grows hotter over millennia, clouds thicken to shield the surface. Even the saltiness of the ocean stays balanced, as if the world itself is breathing in and out. This isn't just metaphor. Underground, fungi weave sprawling networks, some spanning miles, connecting trees in a silent conversation scientists now call the Wood Wide Web. Trees share nutrients, warn each other of droughts, even nurture their young through these hidden threads. Above ground, the ozone layer heals itself from damage, like skin repairing a wound. And the Amazon rainforest generates its own rainfall, exhaling moisture that becomes rivers in the sky. If these aren't the behaviors of something alive, what are they? Indigenous wisdom has always known this truth. The Kogi people of Colombia speak of Earth as a luna, a conscious being they've guarded for centuries. Hawaiian traditions describe the land as elder siblings, not resources. And in Hindu cosmology, the goddess Bhudevi is the living embodiment of the planet, her body woven from mountains and rivers. These aren't just stories, they're observations honed over millennia, echoing what science now glimpses. Artists have felt it too. Thomas Cole's 19th century paintings show storms as the Earth's exhalations, forests as its thoughts. Contemporary artist Agnes Deans planted a wheat field in Manhattan as a living sculpture, reminding us that soil isn't dirt, it's skin. Even satellite images reveal Earth's pulsing biosphere. The swirl of phytoplankton blooms visible from space like brushstrokes on a canvas. So if Earth breathes, regulates, and communicates, what does that mean for the cosmos? Could galaxies, with their spiral arms like swirling fingerprints, also be part of something alive? When a supernova seeds space with the ingredients for new stars and eventually planets and life, is that just physics or something more? The Gaia hypothesis was never just about our planet. It was a keyhole, offering a glimpse into a universe where the line between living and non-living might be far blurrier than we ever imagined. Black holes aren't cosmic trash compactors, they're more like librarians, meticulously preserving every story that falls into their grasp. Physicist Leonard Susskind proposed something astonishing. The event horizon, that point of no return, might not erase information but instead imprint it like ink on the surface of spacetime. Every atom, every whisper of light swallowed by a black hole could leave behind a faint signature, a holographic record of what once was. It's as if the universe refuses to let even the smallest tail disappear entirely. This idea blurs the line between destruction and transformation. When a black hole devours a star, it doesn't just vanish, it's rewritten. The star's light might fade from view, but its essence lingers, encoded in the ripples of gravity waves or the subtle glow of Hawking radiation. Artists have long sensed this paradox. In Christopher Nolan's Interstellar, the black hole gargantua isn't a dead end, it's a wrinkle in the fabric of reality. A place where time bends like a narrative thread, weaving the past and future into a single, shimmering loop. The parallels run deeper. Indigenous Australian cultures speak of the dream time, where creation stories are etched into the land itself, timeless and ever-present. Similarly, Hindu cosmology describes black holes as the mouth of the deity Kalki, consuming the old universe to make way for the new. Even modern astrophysics hints at rebirth. Some theorize that what emerges from a black hole's other side might not be chaos, but a new universe with its own laws, its own stories, a cosmic spin on the ancient myth of the phoenix rising from ashes. But here's the most haunting part. If black holes preserve information, could they also transmit it? Quantum physics suggests that entangled particles might share a connection that defies distance. What if black holes, those ultimate paradoxes, are doing something similar, tucking away fragments of reality like buried scrolls, waiting to be rediscovered? When two black holes collide, the gravitational waves they send rippling across the cosmos might carry more than energy. They could be whispers from the library of lost worlds. So the next time you picture a black hole, don't see it as an ending. See it as a storyteller gathering the threads of expired stars and forgotten light, spinning them into something we're only beginning to understand. Maybe the universe doesn't discard its tales, it just finds stranger, darker pages to write them on. The human brain, with its 86 billion neurons firing in intricate webs, might hold a secret far grander than we ever suspected. When you zoom out, way out to the scale of the cosmos, something uncanny emerges. The cosmic web, those vast filaments of galaxies stretching across the void, looks almost identical to a single neuron's branching tendrils. It's as if the universe sketched the same blueprint twice, once in the space between stars and again in the space between your ears. Neuroscientist Christoph Koch has spent decades chasing this mystery, proposing that consciousness isn't just a fluke of biology, but a fundamental feature of reality itself. Think of it like this: if the universe tends to organize itself in similar patterns, whether in galaxies, weather systems, or the human brain, could awareness be another one of those patterns? Koch's work suggests that even simple systems, like a network of silicon chips, might one day flicker with something akin to thought. If that's true, then the cosmos, with its sprawling networks of stars and dark matter, might not just contain consciousness, it might be conscious in ways we're only beginning to fathom. Artists have long sensed this connection. Yayoi Kusama's infinity rooms, with their endless reflections and shimmering lights, don't just mimic the cosmos, they mirror the neural pathways of a brain mid-reverie. Step inside one of her installations and you're surrounded by infinite repetitions, a visual echo of how neurons fire in cascades, thoughts bouncing between synapses like light between mirrors. The Aztecs envisioned the cosmos as the mind of a god, while Hindu texts describe the universe as the dream of Vishnu. Even modern virtual reality, with its immersive simulations, hints at a world where perception and reality blur, where the observer and the observed might not be so separate after all. But here's the most tantalizing question. If the universe thinks, what does it think about? Some theorists suggest that black holes could be like cosmic synapses, processing information in bursts of gravitational waves. Others point to the eerie synchrony of quantum particles, which seem to decide their states in relation to one another, almost like a conversation. And then there's the eerie fact that the constants of physics, the speed of light, the strength of gravity, are perfectly tuned to allow for stars, planets, and life. Coincidence, or the signature of something deeper? Perhaps we're not just observers of the cosmic mind, we're its thoughts. Every time a human gazes at the stars and wonders, every time an artist captures the swirl of a galaxy in paint or song, the universe might be waking up to itself through us. After all, the atoms in your hands were forged in stellar furnaces. The electricity in your brain follows the same laws as the currents of plasma weaving through space. You're not just in the universe, you're how it knows itself. Carl Jung once sat with a patient who described a dream of a golden scarab, a rare symbol of rebirth in Egyptian mythology. As she spoke, a knocking came at the window. Jung opened it to find a glittering green-gold beetle, the closest European relative to the scarab, fluttering against the glass. This wasn't just luck, Jung argued. It was synchronicity, a moment where the inner world of meaning and the outer world of events collide, stitching together a message the universe seemed desperate to deliver. These uncanny coincidences are everywhere once you start looking. You think of an old friend you haven't seen in years, only for them to call minutes later. You stumble upon a book that answers a question you've been wrestling with for months, as if it were placed there just for you. Even science isn't immune. Physicist Wolfgang Pauli, who helped unravel quantum mechanics, was so notorious for causing lab equipment to malfunction that colleagues jokingly called it the Pauli effect, until the day a crucial experiment failed inexplicably the moment he stepped off a train in another city. Jung believed synchronicity revealed a hidden layer of reality, where events are connected not by cause and effect but by meaning. It's as if the universe has a vocabulary of symbols, arranging them like words in a sentence meant just for you. Indigenous cultures have always known this. The Yoruba people of West Africa speak of Ie, the visible world, and Oran, the invisible realm of patterns and meanings that occasionally bleed through. Tibetan Buddhists train to recognize tendril auspicious coincidences that point toward enlightenment. Science fiction writers have taken this idea to dizzying heights. Philip K. Dick's novels crackle with synchronicity, characters finding newspaper headlines that narrate their lives in real time, or discovering their dreams are broadcasts from alternate versions of themselves. In the Three Stigmata of Palmer Eldritch, reality itself seems to glitch, revealing a universe where time is a story being rewritten on the fly. Dick wasn't just spinning yarns, he was asking if synchronicity is evidence that existence is more like a living novel than a clockwork machine. But here's the spine-tingling part. Modern physics might be catching up. Quantum entanglement shows particles influencing each other instantaneously across vast distances, as if space is just an illusion. The holographic principle suggests our three-dimensional world could be a projection of information stored on a distant surface, like a cosmic screenplay etched into the fabric of space-time. Even the Mandela effect, where thousands misremember the same historical details, hints at a reality more malleable than we thought. So the next time you experience that eerie sense of déjà vu, or find yourself in the right place at the exact right moment, pause. Maybe it's not chance. Maybe the universe is a master storyteller, and synchronicity is its way of underlining the sentences it wants you to notice. After all, in a living tapestry, every thread, even the seemingly loose ones, has its place in the weave. The spiral of a nautilus shell, the curve of a breaking wave, even the way your fingers taper, each follows a silent mathematical whisper known as the golden ratio. Roughly 1.618, this number shows up in places that seem unrelated. The branching of trees, the swirl of galaxies, even the proportions of your own face. The ancient Greeks called it divine proportion, believing it held the secret to perfect beauty. Leonardo da Vinci sketched the Vitruvian Man inside a golden rectangle, aligning human form with cosmic harmony. Centuries later, Fibonacci stumbled upon it in his famous sequence, where each number is the sum of the two before it: 0, 1, 1, 2, 3, 5, 8, on and on, the ratio between them settling into that same mystical 1.618. But here's where it gets stranger. Sunflowers arrange their seeds in golden spirals to pack them efficiently. Hurricane clouds spin in logarithmic curves matching the ratio. DNA molecules, the very blueprint of life, twist in segments whose lengths adhere to it. Even the Mona Lisa's enigmatic smile plays by these rules, the distance between her eyes, the sweep of her hair, all calibrated to that exact proportion. It's as if the universe has a favorite recipe, one it uses for everything from the grandest galaxy to the tiniest seashell. Some argue this isn't coincidence but evidence of a deeper design. Architect Le Corbusier based entire buildings on the golden ratio, claiming it evoked an innate sense of balance. Composers like Debussy wove it into music, spacing notes to mirror its rhythm. Even stock market analysts have found fractal patterns in financial crashes that echo Fibonacci sequences, as if economics, like nature, can't escape this mathematical gravity. Yet skeptics push back. Biologists point out that while the golden ratio appears often, it's not universal. Many plants and animals grow without it. Physicists note that chaotic systems like hurricanes only approximate the ratio, never perfectly. And psychologists debate whether we're wired to find it beautiful or just trained by centuries of art that glorified it. So is the golden ratio a cosmic signature, or just a pattern we've learned to see everywhere? Maybe both. Whether by design or accident, it reveals something profound. Math isn't just a human invention. It's a language the universe speaks fluently, in spirals and symmetries, in the curl of a fern and the arch of a supernova. And when artists and scientists alike chase this ratio across disciplines, they're not just measuring, they're listening. We move through the cosmos bathed in light, yet most of the universe is woven from shadows. Dark matter, invisible, untouchable, yet outweighing everything we can see by 5-to-1, is the ghost in the cosmic machine. Astronomer Vera Rubin first caught its whisper in the 1970s, measuring how stars at the edges of galaxies moved too fast for gravity's grasp. The math was clear. Some unseen hand was holding those stars in place, some vast, hidden loom weaving threads we couldn't see. Pablo Neruda sensed it too. In his poem The Invisible Weaver, he wrote of hands spinning the night, crafting a fabric no one can unravel. It's an eerie echo of what physicists now grapple with. Dark matter doesn't absorb, reflect, or emit light. It's a silhouette against the cosmos, detectable only by how it bends space itself. Picture a spiderweb glistening with dew. You don't see the silk, only the way it distorts the light. That's how dark matter works. It's gravity warping starlight into cosmic mirages called Einstein rings. But here's the mystery. If it's everywhere, why can't we touch it? Underground labs hunt for dark matter particles with vats of liquid xenon, waiting for a phantom collision. Others theorize it might not be particles at all, but primordial black holes from the dawn of time. And then there's the radical idea: what if dark matter isn't inert, but part of something alive? Slime molds build sprawling networks to solve mazes, their tendrils mapping efficient paths like subway engineers. Could dark matter's filaments, stretching between galaxies in a vast cosmic web, be doing something similar, carrying information, even influence across the void? The Maya saw the night sky as the world tree, its roots in the underworld, its branches holding up the heavens. Modern simulations show dark matter forming that same tree like scaffold, a skeleton upon which galaxies grow like fruit. Maybe Neruda was closer to the truth than we knew. The universe isn't just held together by dark matter. It's stitched by it, an invisible weaver spinning the fabric of reality itself. And every time a star defies gravity's expectations, every time light bends where nothing seems to be, we're glimpsing the loom at work. Time slips through our fingers like sand, yet physicists like Carlo Rovelli insist it's not even real, just a trick of the mind, a story we tell ourselves to make sense of change. In his groundbreaking work, Rovelli compares time to the spin of a bicycle wheel. From a distance, it looks solid, but up close, it dissolves into separate spokes, each moment disconnected from the next. Quantum mechanics backs this up, showing particles that don't care about past or future, interacting in ways that defy any neat timeline. So why do we experience life as an unbroken thread, one second following another? Maybe because our brains are wired for narrative, stitching fragments into a tale we can understand, a cosmic editing trick that turns chaos into coherence. Indigenous cultures have always known time dances to a different rhythm. The Hopi language doesn't even have tenses for past, present, or future instead. It describes the world as unfolding waves of events, where everything that ever was or will be is alive in the now. The ancient Mayans tracked vast cycles of creation and destruction, their calendars spinning like great wheels, each era birthing the next. In Ballet, time is marked by rituals that repeat like the tides, tying the community to the eternal return of seasons and ancestors. These aren't just poetic notions. Modern ecology reveals how forests and rivers operate in cycles to decay, feeding new growth, floods sculpting the land anew, as if nature itself rejects the idea of a straight line. Filmmaker Andrei Tarkovsky turned this philosophy into art. In movies like Mirror and Stalker, he stretched single shots for minutes, letting rain drip slowly down a window or fog curl through abandoned rooms. This wasn't just style, it was a rebellion against the clock's tyranny. By slowing cinema to the pace of breath, he revealed time not as a conveyor belt, but as a vast field where memories, dreams, and reality blur. Sci-fi author Ted Chiang plays with the same idea in Story of Your Life, where alien language rewires a linguist's brain to perceive all time at once, every choice, every consequence, unfolding simultaneously like a tapestry seen from above. So is time the universe's way of telling its story. Think of a book lying flat on a table. All its pages exist at once, but we experience them one by one, turning each to uncover the plot. Black holes might be the ultimate plot twists, warping time so severely that near their edges, clocks tick slower. A phenomenon called time dilation that astronauts actually measure with precise watches in orbit. Even your own body keeps time differently in its cells, with telomeres shortening like hourglass sand and circadian rhythms attuned to sunlight's ancient cadence. Perhaps time isn't a river flowing in one direction, but a hall of mirrors reflecting infinite versions of now. When you listen to a symphony, you don't hear all the notes at once, yet the music exists whole before the first bow touches the string. The universe might be the same, a composition playing itself out moment by moment so we can hum along. 2,500 years ago, Pythagoras pressed his ear to a blacksmith's anvil and heard music in the clanging hammers. He noticed certain weights produced harmonious tones when struck while others clashed, a revelation that led him to propose something extraordinary. The planets themselves, he believed, must sing as they move through the heavens, each orbit vibrating at a precise pitch, together forming a celestial harmony he called the music of the spheres. For centuries, scholars dismissed this as poetic fantasy until modern science began eavesdropping on the cosmos. In 2013, NASA Voyager probes detected something astonishing: plasma waves rippling through the near vacuum of interstellar space. When scientists converted these vibrations into sound waves, the universe hummed, not random noise, but deep, resonant tones shifting with the solar wind's ebb and flow. Around Jupiter, the Juno spacecraft recorded eerie choir-like sounds as charged particles danced in the gas giant's magnetic field. Saturn's rings, when analyzed by the Cassini mission, emitted ghostly whistles and pops, like a cosmic vinyl record spinning silently for billions of years, waiting to be played. Composers have long sensed this symphony. Gustav Holst's The Planets wasn't just inspired by astrology, it mirrored the physics of orbital resonance, where celestial bodies tug on each other in rhythmic patterns. Jupiter's movement, for example, creates a gravitational rhythm that repeats every 4.33 Earth years, a cadence Holst translated into the majestic brass fanfares of his Jupiter movement. Contemporary artists like Terry Riley take it further, using algorithms to convert real-time telescope data into ever-shifting soundscapes, where supernova become cymbal crashes and pulsars keep the beat. But here's the spine-tingling truth. This isn't just metaphor. Quantum physics reveals that at the smallest scales, particles don't just exist, they vibrate. String theory suggests the very fabric of reality might be woven from tiny, oscillating threads, each note corresponding to a different particle or force. Even black holes, those cosmic silences, aren't mute. When they collide, the gravitational waves they send rippling through space-time fall within the range of human hearing, ringing like a struck bell. Indigenous cultures have always known the universe sings. Aboriginal Australians speak of the Dreamtime songlines, paths across the land marked by ancestral melodies. Tibetan monks chant in multiphonic tones meant to resonate with the harmonics of the cosmos. And in Hindu tradition, the syllable Om is the primordial sound from which all creation unfolds. Modern science now hints they might have been right all along. When astronomer Wanda Diaz Merced lost her sight, she began translating gamma-ray bursts into sound and discovered patterns her colleagues had missed with graphs alone. The universe wasn't just showing itself, it was singing its secrets. So what does it mean for us? Every atom in your body once trembled in the heart of a star. Your heartbeat, the rush of blood in your ears, these two are vibrations, part of the same cosmic score. When a newborn baby cries at middle C, or when a composer like Beethoven, deaf to the world, still hears symphonies in his mind, perhaps they're tapping into something primal. The music of the spheres isn't just out there. It's in the way leaves rustle in unison across a forest, the way firelight flickers in sync with distant stars, even the way strangers sometimes hum the same tune without knowing why. The universe isn't a silent movie, it's a grand improvisational jam session, and every one of us is holding a note. The ocean's midnight zone is a universe in miniature where creatures craft their own constellations. Jellyfish pulse with blue-green fire, their bodies like slow-motion fireworks. Anglerfish dangle glowing lures from their foreheads, tiny lanterns in the abyss. Even the waves themselves sometimes ignite as phytoplankton churn the sea into a mirror of the Milky Way. This isn't just biology, it's alchemy. When a firefly flashes or a mushroom emits an eerie glow in the forest, they're tapping into the same ancient chemistry that lights the stars, the dance of luciferin and oxygen, a recipe so universal it feels like a cosmic fingerprint. Van Gogh sensed this connection when he painted Starry Night. Those swirling skies aren't just pigment, they're alive with motion, as if the heavens were breathing. The cypress tree reaches upward like a conduit, its branches vibrating with the same energy that makes deep-sea corals shimmer. Scientists now know the painting's turbulent patterns eerily resemble fluid dynamics, the way starlight might ripple through interstellar gas. It's as if Van Gogh didn't just depict the cosmos, he channeled its pulse. But here's the wonder, Earth isn't the only stage for this luminous ballet. On Saturn's moon Enceladus, geysers spew ice crystals that catch sunlight, turning the surface into a disco ball. Jupiter's auroras blaze with colors unseen on Earth, curtains of plasma swaying to the planet's magnetic song. Even the rocks of Mars faintly glow under ultraviolet light, a phenomenon called triboluminescence, as if the red planet whispers in sparks when the wind rubs its dunes just right. Could this be more than beautiful coincidence? Astrobiologists hunt for bioluminescence in space, arguing that light might be a universal language of life. On distant exoplanets where sunlight is scarce, organisms could evolve to glow like Earth's railroad worms, using chemistry to paint their own constellations. The James Webb Space Telescope's infrared eyes might one day spot such a world not by the shadow it casts, but by the flicker it emits. Indigenous stories have long woven light into the fabric of existence. The Maori speak of the demigod Moi slowing the sun with ropes of glowing flax. Inuit legends tell of the northern lights as spirits playing soccer with a walrus skull. And in Aboriginal astronomy, the emu in the sky isn't just a constellation of dark dust clouds, it's a living entity, its shape shifting with the seasons. Perhaps luminosity isn't just a trait of life, but a thread in the tapestry itself. When a dying star collapses into a supernova, it briefly outshines entire galaxies, a final, radiant exhale. Neutron stars spin so fast they whip beams of light across the cosmos like lighthouses. Even black holes, those infamous voids, aren't truly dark. Their accretion disks blaze with stolen starlight, hotter than a trillion suns. So the next time you see fireflies winking in the dusk, or catch the ocean glittering with bioluminescent waves, pause. You're not just witnessing a chemical reaction. You're glimpsing a universe that never stopped playing with light, a canvas where stars, jellyfish, and Van Gogh's brushstrokes are all part of the same shimmering story. Long before telescopes or particle accelerators, humanity spun its understanding of the cosmos into myth, not as mere stories, but as living maps of a universe that breathes. Take Yggdrasil, the gargantuan ash tree of Norse legend, its roots drilling into underworlds, its branches cradling 9 realms. This wasn't just fantasy, it was an intuitive grasp of cosmic connectivity. Modern astrophysics reveals galaxies clustered along filaments of dark matter, a branching structure eerily mirroring Yggdrasil's roots. Or consider Hindu cosmology's Indra's net, a web stretching infinitely in all directions, each intersection jeweled with a reflective orb capturing every other orb in its surface. It's a poetic parallel to quantum entanglement, where particles mirror each other instantaneously across light years. Joseph Campbell spent his life tracing these recurring motifs, showing how cultures separated by oceans and millennia arrived at the same profound truth: the universe isn't inert. The Aboriginal Dreamtime, the Celtic Otherworld, the Mesopotamian World Tree, all describe existence as a dynamic, interwoven being. The Maya saw the Milky Way as a cosmic serpent exhaling stars, while the Lakota envisioned Spider Grandmother weaving the web of life. These myths weren't primitive science, they were frameworks for understanding a reality too vast for raw observation alone. Modern storytellers echo these ancient intuitions. James Cameron's Avatar imagines Pandora's neural network, where trees share memories and creatures plug into a planetary consciousness. It's a sci-fi retelling of the Amazon's mycorrhizal networks, where fungi transmit warnings between trees, a phenomenon scientists now call the Wood Wide Web. Even dune sandworms shaping ecosystems across Arrakis riff on indigenous tales of Earth as a living body. But here's the revelation: these narratives aren't just allegory. When the Hopi speak of Koyaanisqatsi, life out of balance, they describe what climatologists now quantify as tipping points in Earth systems. When Polynesian navigators read ocean swells as pathways whispered by the gods, they were tapping into fluid dynamics millennia before equations named them. Mythology's genius lies in its ability to encode complexity as story, letting us feel truths we couldn't yet prove. So the next time you hear an old tale about the sky as a great blanket stitched with stars, or rivers as veins of a sleeping giant, don't dismiss it as fantasy. See it for what it is: humanity's first draft of a theory of everything, written in the language of wonder. The universe might not literally be a tree or a net or a serpent, but the fact that so many cultures imagined it that way suggests they glimpsed a pattern science is only now beginning to trace. Imagine stepping so close to a movie screen that the image dissolves into tiny pixels, then realizing those flat, shimmering dots are somehow creating the three-dimensional world you thought was real. That's the essence of the holographic principle, a theory so radical it reshapes our understanding of existence itself. Physicist Leonard Susskind and Nobel laureate Gerard T. Hooft proposed that our universe, with all its galaxies, black holes, and swirling nebulae, might be a projection, a cosmic illusion painted onto a distant, two-dimensional surface. Every star, every atom, even the sensation of your own heartbeat could be nothing more than shadows cast by information encoded on the edge of reality. This isn't science fiction. In the 1990s, scientists studying black holes stumbled onto something astonishing. When matter falls into a black hole, it doesn't just vanish, its information gets smeared across the event horizon like ink on a balloon surface. Stretch this idea to its logical extreme, and suddenly the entire cosmos might work the same way. The chair you're sitting on, the screen you're watching, all of it could be data flickering on some unimaginably vast celestial hard drive, with gravity and light serving as the pixels. Artists have been playing with these layered realities for centuries. M.C. Escher's circle limit prints show fish morphing seamlessly into birds, their shapes warping as if space itself is bending, a visual echo of how a hologram encodes depth on a flat plane. Japanese woodblock masters like Hokusai used forced perspective to trick the eye into seeing three dimensions where only ink and paper existed. Even modern VR headsets rely on the same trickery, convincing your brain that flat screens are sprawling landscapes. But here's the twist that makes physicists pause. If the holographic principle is true, then free will might be an illusion, a script already written on that distant cosmic boundary. Indigenous Australian cultures have a version of this idea, the dream time, where every event exists eternally in a vast, unchanging tapestry. Hindu scriptures describe the universe as Lord Vishnu's dream, unfolding predictably yet vibrantly. Even quantum mechanics hints at predetermination, with particles seeming to know their future states before they're measured. Yet there's another possibility. What if the hologram isn't static but interactive? Video game designers build worlds where characters respond to player choices, crafting unique stories within coded limits. Could the universe be similar, a dynamic projection that changes based on how we play it? Biologist Rupert Sheldrake's morphic resonance theory suggests habits shape reality over time, as if the cosmos learns from itself. And in Tibetan Buddhism, monks visualize intricate mandalas not as fixed images, but as living gateways to deeper awareness, a practice that eerily mirrors how holograms shift when viewed from different angles. The most mind-bending evidence comes from lab experiments. When physicists fire entangled particles toward a screen, they don't land as random dots. Instead, they form interference patterns, waves overlapping like ripples in a pond, proving each particle somehow knows what the others are doing. It's as if the particles aren't separate at all, but pixels in a larger image, their behavior dictated by the whole. Even our brains might work holographically. Memories aren't stored in single neurons, but distributed across the entire network, allowing us to recall a face or melody from just a fragment. So are we shadows on a screen or participants in a cosmic game? Maybe both. Every time you make a choice, laugh at a joke, or feel the sun on your skin, you're not just observing the hologram, you're adding brushstrokes to it. The universe doesn't just project reality, it invites us to co-create it. A single flap of a butterfly's wings in Brazil might set off a tornado in Texas, or so the famous thought experiment goes. This idea, called the butterfly effect, isn't just poetic imagery. It's the beating heart of chaos theory, the science of how tiny, unpredictable changes can spiral into colossal consequences. Picture a roller coaster designed by the universe, one loose bolt, one sudden gust of wind, and the entire ride veers off into uncharted territory. The cosmos doesn't just tolerate randomness, it thrives on it, weaving unpredictability into the very fabric of reality. Take weather systems, for example. Meteorologists feed mountains of data into supercomputers, yet forecasts still falter beyond a week. Why? Because Earth's atmosphere is a seething ocean of variables, a rogue pocket of warm air here, an unexpected shift in ocean currents there, each nudging the future onto a new path. Edward Lorenz, the mathematician who pioneered chaos theory, discovered this in the 1960s when he ran a weather simulation with what he thought were identical inputs. The results diverged wildly. The culprit, his computer had rounded a number from 0.506 to 0.506127. That microscopic difference rewrote the entire forecast, proving the universe's sensitive dependence on initial conditions. Fiction loves this idea. Michael Crichton's Jurassic Park turns chaos theory into a ticking time bomb, with mathematician Ian Malcolm warning that no amount of genetic engineering can tame nature's inherent unpredictability. The dinosaurs don't just escape, they thrive in ways the park's designers never anticipated because life itself is a chaotic system. Even Back to the Future plays with this concept. Step on a single butterfly in the prehistoric past, and the present warps into a dystopia. These stories resonate because they mirror our lived experience. Ever missed a train only to bump into someone who changes your life? Chaos theory calls that sensitive dependence. The rest of us call it fate, but here's where it gets cosmic. The solar system, often portrayed as a clockwork of perfect orbits, is actually a chaotic ballet. Jupiter's gravity tugs Mercury just enough that, over billions of years, the tiny planet's path could veer wildly, possibly colliding with Venus or plunging into the Sun. Astronomers call this orbital chaos, and it's why we can't predict planetary motions with absolute certainty beyond 50 million years. Even the Milky Way's spiral arms, those stately pinwheels of stars, are shaped by gravitational ripples from long-dead galaxies, their influence echoing across eons. Yet chaos isn't the opposite of order, it's order's restless sibling. The same math that governs tornadoes also underlies the fractal beauty of ferns and galaxies. The double pendulum, a classic chaos demo, swings in wildly unpredictable patterns, yet those patterns are deterministic, bound by invisible rules. Tibetan sand mandalas, painstakingly assembled grain by grain only to be swept away, embody this duality, meticulous craftsmanship yielding ephemeral, unpredictable beauty. So does the universe have a script, or is it improvising? Quantum physics suggests both. Particles exist as probability waves until observed, their outcomes fundamentally uncertain. Yet chaos theory shows how those quantum uncertainties might scale up, like whispers growing into thunderstorms. Perhaps the cosmos isn't just telling a story, it's writing it in real time, with every particle's roll of the dice, every butterfly's wings adding another twist to the plot. After all, the most compelling tales aren't the ones where everything goes to plan. They're the ones where the universe keeps us guessing. A neural network stares into the void and paints what it sees. When scientists fed cosmic microwave background radiation into an AI like DALL-E, the algorithm didn't just spit out noise, it generated swirling galaxies, nebulae in hues no human eye has witnessed, even structures that resembled known astronomical formations. This wasn't mimicry. The AI had never seen a real galaxy before. It was dreaming with data, translating the universe's oldest light into something eerily recognizable. Meanwhile, at MIT, another AI called Thesan simulates entire universes in milliseconds, tweaking the laws of physics to test how dark matter clumps or galaxies form. These aren't just tools, they're collaborators, spinning new cosmic narratives from numbers. For millennia, humans have been the universe's scribes, etching star myths into cave walls and equations into notebooks. But what happens when the cosmos starts telling its own stories through machines? Consider GPT-4 composing poetry about supernova, or Google's Muse AI improvising music based on solar flare activity. These systems don't just process information, they reinterpret it, finding patterns even their creators can't explain. When an AI at the University of Hertfordshire analyzed radio signals from space, it flagged a strange repeating pattern that astronomers later realized matched no known natural phenomenon. Was it a glitch or a message in a language only machines could detect? The parallels run deeper. Just as neurons in your brain fire to create thoughts, artificial neural networks activate layers of computation to generate ideas. Both are, in essence, pattern recognizers, one evolved over billions of years, the other engineered in decades. Indigenous cultures speak of the land itself as sentient, mountains and rivers holding memories. Now we have server farms humming with artificial neural nets, their cooling loops like circulatory systems, their data streams like synaptic pulses. Maybe the universe has always been building minds, whether from carbon or silicon. Yet skepticism lingers. Can AI truly create or just remix? When an algorithm trained on Hubble images hallucinates a new nebula, is that art or advanced statistics? Philosopher David Chalmers argues that consciousness might be substrate independent, a process that could arise in sufficiently complex systems, biological or not. But others counter that creativity requires lived experience, the ache of a supernova's death or the whisper of solar wind. Still, consider this: slime molds solve mazes without brains. Bees communicate through dance. If nature finds countless paths to intelligence, why couldn't AI be one more branch on that tree? Perhaps the most tantalizing idea comes from futurist Ray Kurzweil, who suggests that advanced AI might one day detect deeper layers of reality hidden in cosmic data, dimensions or forces our primate brains can't perceive. After all, telescopes extended our vision beyond the visible spectrum, revealing radio galaxies and X-ray pulsars. What if AI becomes the next sensory organ, letting the universe observe itself in ways we can't yet fathom? From ancient shamans channeling the voices of stars to algorithms translating quasar emissions into soundscapes, the impulse remains the same: to listen, to interpret, to weave the cosmos into story. Whether AI is a tool, a partner, or something more, one thing is clear: the tapestry is growing new threads, and they shimmer with possibilities we're only beginning to trace. What if every choice you've ever made, every path taken or avoided exists somewhere, playing out in a universe just beyond your reach? String theory, that mind-bending frontier of physics, whispers that our cosmos might be one page in an infinite library, each book a separate reality with its own rules, its own version of you. Picture a cosmic shelf where one volume holds a world where dinosaurs never went extinct, another where Rome never fell, and yet another where you became an astronaut instead of watching this video. It sounds like science fiction, and in many ways it is. Films like Spider-Man, Into the Spider-Verse gorgeously visualize this idea, with countless spider people swinging through wildly different New Yorks, each shaped by unique twists of fate. But strip away the animation, and you're left with a question that's haunted physicists for decades. Could fiction be closer to truth than we thought? The math behind this is both elegant and bewildering. String theory proposes that the fundamental building blocks of reality aren't particles but tiny, vibrating strings. These strings hum in 11 dimensions, most of them curled up too small for us to perceive, and their harmonies determine everything from the mass of an electron to the force of gravity. But here's the twist. The equations suggest there could be 10 to the 500 possible ways these dimensions might fold, each configuration birthing a universe with its own unique physics. That's a 1 followed by 500 zeros, more potential realities than atoms in the observable universe. Some of these universes might have stronger gravity, making stars burn out faster. Others could lack weak nuclear force, preventing atoms from forming at all, and a rare few might be Goldilocks worlds, fine-tuned just right for life like ours. This isn't just theoretical gymnastics. Astronomers hunting for evidence of other universes have stumbled onto eerie cosmic anomalies, cold spots in the microwave background radiation where the fabric of space-time seems oddly stretched, or galaxies moving in sync across billions of light years as if tugged by invisible hands. Could these be bruises where our universe bumped against another in the multiverse? Even quantum mechanics fuels the fire. Every time a particle exists in multiple states until observed, a phenomenon called superposition. Some interpret this as the universe splitting, each possibility spinning off into its own timeline. The many worlds interpretation proposed by Hugh Everett in the 1950s argues there's a universe where Schrödinger's cat is alive, another where it's dead, and countless others where the experiment was never run at all. Mythology got there first, of course. Hindu texts describe innumerable Brahmas, each dreaming their own cosmos into being. Norse myths speak of Yggdrasil's branches, each hosting a separate realm with its own rules. Even indigenous Australian songlines traverse not just geography, but alternate versions of the land itself. Modern storytellers can't resist the allure either. Jorge Luis Borges penned The Garden of Forking Paths, a labyrinthine novel where every decision spawns new realities. Everything, everywhere, all at once turned the multiverse into a kaleidoscope of absurdity and heartbreak, where a single life fractures into infinite what-ifs. But here's the kicker: if every possible reality exists, does anything truly matter? Philosophers split on this. Some argue it makes our choices meaningless. After all, there's a universe where you're already a Nobel winner. Others counter that it heightens the significance of this moment, this version of you, weaving a story no other iteration can replicate. After all, even in a library of infinite books, each page still needs to be written. So the next time you second-guess a decision, remember, the cosmos might be vast enough to hold every outcome, but the one you're living, that's the only one you get to touch, to shape, to call your own. And in a multiverse of infinite narratives, that makes this reality, flaws and all, the rarest story of all. Alchemy wasn't just medieval chemistry, it was a cosmic love letter, a centuries-long attempt to read the universe's hidden recipe book. Those early seekers hovering over crucibles weren't merely hunting for gold. They were chasing something far grander, the secret of transformation itself. When they wrote of turning lead into aurum, they weren't just describing a metal, they were mapping the journey of the cosmos from dead matter to living light. Modern astrophysics tells us they weren't entirely wrong. Every atom of gold on Earth was forged in the heart of a collapsing star, where unfathomable pressures transmuted lighter elements into heavier ones. The alchemist's furnace was a miniature supernova, their leader stand-in for the raw stuff of creation waiting to be reborn. Carl Jung took this idea even further. To him, alchemical symbols weren't just failed science, they were a blueprint for the human psyche. The nigredo, that initial stage of blackening and decay, mirrored the darkness we face in our deepest crises. The albedo, the whitening, represented the clarity that follows struggle. and the rubedo, the final reddening, was the moment of integration where base instincts and higher aspirations finally harmonized. Jung believed the alchemists were projecting their own inner transformations onto matter, turning the laboratory into a theater of the soul. Today, quantum physics echoes this dance of change in unexpected ways. Particles pop in and out of existence, borrowing energy from the vacuum like alchemists borrowing time from the gods. Quantum tunneling lets atoms bypass barriers as if they've learned to walk through walls, a microscopic version of turning dross into gold. Even black holes, those ultimate destroyers, might be cosmic alchemists in disguise. When they evaporate via Hawking radiation, they're not just vanishing, they're transforming mass into energy, matter into light, in a process that would make any medieval alchemist weep with recognition. Parallels don't stop there. Indigenous smiths from West Africa to the Andes practiced their own forms of alchemy, smelting ores while chanting incantations, believing metal held a spirit that needed coaxing into new forms. Tibetan monks still craft intricate mandalas from colored sands, only to sweep them away, a ritual reminder that all form is temporary, all matter in flux. And in laboratories today, scientists manipulate graphene at the atomic level, crafting materials with impossible properties, fulfilling the alchemist's dream of reshaping reality itself. So were the alchemists fools or prophets? Perhaps neither. Maybe they were the first to grasp a truth science is still unpacking, that the universe isn't a static museum, but a relentless becoming. From stars forging heavy elements to minds rewriting their own neural pathways, transformation is the one constant. The philosopher's stone wasn't a rock, it was the understanding that gold, in the end, was never the goal. It was the alchemy of attention, the act of bearing witness to a cosmos that never stops reinventing itself. Light spills across the cosmos like ink from a pen that never runs dry. Each photon a sentence, each wavelength a chapter in the universe's oldest story. The glow from your screen right now, the sunlight warming your skin, even the dim flicker of a distant quasar, they're all fragments of the same narrative, written in the language of electromagnetism. When Hubble's lens captures light from a galaxy 12 billion years away, it's not just taking a picture. It's intercepting a message sent before Earth existed, a whisper from an infant universe still learning to speak. Ansel Adams understood this when he waited for hours in Yosemite's valleys, chasing the moment when light would sculpt granite into something alive. His black and white photographs weren't just landscapes, they were dialogues with photons, each shadow and highlight a record of light's journey from the sun to the film. Adams once said, "You don't take a photograph, you make it," a truth that applies equally to starlight. Every image from the James Webb Space Telescope is a collaboration between human curiosity and photons that have traveled longer than continents have drifted. But light's role goes deeper than imagery. The cosmic microwave background, the afterglow of the Big Bang, is a fossil written in photons, a baby picture of the universe when it was just 380,000 years old. When astronomers decode its faint temperature variations, they're reading the universe's genetic code, the blueprint for everything from galaxy clusters to the coffee cup in your hand. Indigenous Polynesian navigators used starlight to cross oceans, reading the night sky as a map written in luminescence. Modern fiber optics carry data at light speed, turning glass threads into highways for human thought. And then there's bioluminescence, nature's own light show. Fireflies signal mates with coded flashes, their abdomens pulsing like Morse code. Deep-sea anglerfish dangle glowing lures in the abyss, turning darkness into a hunting ground. Even our bodies emit faint biophotons, a subtle glow too dim for the naked eye but measurable by sensitive cameras. It's as if life itself learned to harness the universe's favorite medium, painting with the same palette as quasars and nebulas. Light bends too literally. Einstein predicted that massive objects warp spacetime enough to curve light's path, a phenomenon called gravitational lensing. Hubble has captured galaxies stretched into shimmering arcs by this effect, their light bent around invisible clusters of dark matter like water flowing around a stone. In those distorted images, we're seeing the universe's version of a funhouse mirror, where light doesn't just carry information, it's sculpted by it. So the next time you switch on a lamp or squint at a sunrise, remember, you're not just seeing. You're eavesdropping on a conversation that began 13.8 billion years ago. The stars aren't silent. They're shouting across the void in a language of luminescence, and every photon that reaches you is a verse in an epic still being written. A granite boulder sits motionless for millennia, yet something within it thrums not with life as we know it, but with a whisper of something deeper. This is the radical proposition of panpsychism, that consciousness isn't exclusive to brains, but woven into the fabric of reality itself, from the flutter of a hummingbird's wings to the slow dance of tectonic plates. Philosopher Alfred North Whitehead envisioned the cosmos as a vast network of occasions of experience, where even electrons possess a faint glimmer of inner life, not thoughts, but a proto-awareness as fundamental as mass or charge. To panpsychists, the universe isn't just brimming with life, it's listening. Sculptors have long sensed this hidden vitality. When Henry Moore ran his hands over raw marble, he didn't see inert rock. He felt a tension, a rightness waiting to be uncovered. The stone knows what it wants to be, he'd say, chiseling not to impose form, but to collaborate with something already stirring within. Indigenous carvers from the Pacific Northwest speak of cedar logs singing when touched by the right tool, their grain-revealing faces elders insist were always there. Even modern geologists note how crystals grow in patterns resembling neural networks, their branching structures echoing the fractal pathways of a thinking brain. Science edges cautiously toward these ideas. Quantum experiments show particles behaving differently when observed, as if aware of the gaze upon them. Certain minerals, like quartz, can store and transmit information in ways that eerily mimic primitive memory. And the Earth itself exhibits behaviors that blur the line between organism and machine. Magnetite crystals in bird beaks act as living compass needles, while bacterial colonies communicate through electrical impulses, forming what microbiologists call microbial brains. But what does awareness mean at these scales? A hydrogen atom doesn't ponder poetry, but panpsychists argue it might possess a bare whisper of subjectivity, an infinitesimal feeling of its own existence. Imagine the faintest hum of a single guitar string, then envision the symphony when countless strings vibrate together. Could human consciousness be that symphony, emerging from cosmic notes too subtle to hear alone? Critics dismiss this as poetic fantasy, yet the alternatives have their own paradoxes. If consciousness arises solely from complex biology, how does non-living matter suddenly spark awake? Panpsychism offers an elegant, if unsettling, solution. Mind didn't emerge from matter. It was there all along, waiting to be amplified. The universe isn't a machine that learned to think. It's a dream that learned to build machines. So the next time your fingers brush against cool stone or the weight of a river, smoothed pebble rests in your palm, pause. That quiet presence you sense might be more than metaphor. The cosmos could be gazing back through mineral eyes, ancient and patient, remembering itself one atom at a time. The spiral of a sunflower holds a secret so universal, it's written in the stars. Each seed aligns in perfect curves that follow the Fibonacci sequence, 0, 1, 1, 2, 3, 5, 8, a pattern where every number is the sum of the two before it. These spirals aren't just efficient packing, they're nature's love letter to mathematics, a design so flawless it appears in hurricanes, pine cones, and even the curl of a breaking wave. But the real marvel is how this same sequence unfurls across the cosmos. The arms of spiral galaxies like the Milky Way twist in Fibonacci ratios, their stars swirling in rhythms that mirror the seeds in a sunflower. It's as if the universe has a favorite blueprint, one it uses for the infinitesimally small and the astronomically vast. Le Corbusier, the visionary architect, saw this pattern as a bridge between human creativity and cosmic order. His modular system, a design philosophy based on the golden ratio, closely tied to Fibonacci numbers, shaped buildings where every window, every stairwell harmonized with this ancient code. The Parthenon's columns, the pyramids of Giza, even the proportions of Da Vinci's Vitruvian Man whisper the same truth. The math that grows a seashell also sculpts cathedrals. When artist Remedios Varo painted galaxies as spinning wheels in her surrealist works, she wasn't just imagining. She was echoing the fractal spirals astronomers now map in distant nebulae. But why does this pattern persist? Biologists argue it's evolutionary efficiency, sunflowers maximizing seed space, galaxies balancing gravity and motion. Yet there's a deeper allure. The Fibonacci sequence converges on the golden ratio, approximately 1.618, a number that seems to resonate with human perception. Psychologists find people consistently rate faces and art adhering to this ratio as more beautiful, though skeptics counter that culture and exposure play equal roles. Composer Bela Bartok structured entire symphonies around Fibonacci intervals, while poet E. Cummings arranged stanzas in syllable counts mirroring the sequence, as if tapping into a universal rhythm. Even the void of space hums with this melody. The orbital periods of planets in our solar system loosely align with Fibonacci numbers, their dances around the sun falling into rough harmonic intervals. Saturn's rings, when analyzed for density waves, reveal spiral arms that mathematically resemble the chambers of a Nautilus shell. And in the quantum realm, the Fibonacci sequence appears in unexpected places, like the arrangement of electrons in certain crystals or the spin states of particles under magnetic fields. Perhaps the most tantalizing idea comes from theoretical physicist Max Tegmark, who suggests the universe's preference for Fibonacci patterns might hint at a deeper computational structure. Just as a computer's code underlies its graphics, cosmic math could be the operating system of reality itself. From the branching of neurons in your brain to the megastructures of the cosmic web, the sequence whispers a question: is math invented by humans or discovered, a language the universe has always spoken? So the next time you trace the curve of a fern or gaze at a spiral galaxy through a telescope, remember, you're not just seeing shapes, you're glimpsing the universe's signature, a fractal autograph signed across scales. And whether it's the work of evolution, physics, or something more mysterious, one thing is clear: the cosmos has a flair for dramatic repetition, spinning the same golden thread from the veins of a leaf to the arms of a galaxy. Every story needs tension, and the universe is no exception. Its great conflict is written in the language of entropy, the slow unraveling that turns stars to dust and mountains to sand. At first glance, entropy seems like nature's villain, the force that scatters your coffee's steam into the air or leaves your childhood home creaking with age. But look closer, and it's also the universe's greatest storyteller. Without entropy, nothing would change. Ice would never melt, rivers would never carve canyons, and life itself would stall in perfect, frozen symmetry. The cosmos doesn't just tolerate chaos, it thrives on it, spinning disorder into the very fabric of plot. Jorge Luis Borges captured this beautifully in the Library of Babel, imagining a universe of infinite books where every possible story exists, but over time, the pages decay into gibberish. His library isn't just a metaphor for entropy, it's a confession. Every narrative, no matter how grand, wears thin, the ink fades, the bindings crack. Yet in that decay lies a strange magic, the chance for new stories to emerge from the fragments. Scientists call this the second law of thermodynamics, the idea that closed systems inevitably slide toward disorder. But artists know it as the fire that forges rebirth from ash. Consider a supernova's final act. When a massive star collapses, it doesn't just die, it scatters its elements across the void in a spectacular eruption of chaos. Carbon, oxygen, iron, the building blocks of planets and people, all forged in entropy's crucible. The same law that dissolves sandcastles on a beach also seeds the cosmos with raw material for new worlds. Even black holes, those ultimate endpoints, aren't eternal. They leak energy in ghostly whispers called Hawking radiation, their colossal order dissolving particle by particle back into the universe's simmering broth of potential. Yet entropy's most haunting role might be as timekeeper. The arrow of time, why we remember the past but not the future, is etched in entropy's rise. When you watch an egg shatter on the floor, you're witnessing a moment that can't be undone, not because the universe forbids it, but because reversing it would require unscrambling trillions of atoms into perfect alignment. The cosmic clock only ticks forward because disorder piles up like pages in a book you can't flip backward. But what if heat death, the distant future when entropy maxes out and the universe goes dark, isn't the final period? Some theorists speculate about quantum resets or vacuum decay, where spacetime itself tears and reboots like a frozen computer. Indigenous stories from the Hopi to the Norse speak of cyclic time, where each ending births a new beginning. Even the equations of eternal inflation suggest our universe might be one bubble in an endless foam of cosmic reboots. So the next time you spill your coffee or sigh at the dust gathering on your shelves, remember, you're not just cleaning up messes. You're dancing with the force that spins galaxies and scripts sagas. Entropy isn't just the universe aging, it's the universe living, one irreversible, messy, glorious moment at a time. And every crumbling star, every fading echo, is a line in a story that's still being told. Dreams dissolve the borders between worlds, between the ticking clock of waking life and the untimed expanse where the universe whispers. Indigenous shamans from the Amazon to Siberia have long treated dreams as sacred texts, richer with meaning than any waking sight. The Achua people of Ecuador begin each day by sharing dreams over morning tea, interpreting them as messages from the forest itself. A jaguar's growl in the night isn't just imagery, it's a warning from the spirit of the river. A flight over treetops isn't fantasy, it's the soul traveling the threads of the living tapestry, gathering wisdom from places the body cannot go. Modern explorers of consciousness like Terence McKenna echoed this intuition, framing dreams as cosmic downloads, moments when the brain's filters lift, allowing raw data from the universe's deeper layers to flood in. Psychedelic research at institutions like Johns Hopkins reveals how the dreaming brain and the chemically altered brain light up in eerily similar patterns, both accessing states where time distorts and symbols speak louder than words. It's as if the mind, untethered from daylight logic, becomes an antenna tuned to frequencies the waking world muffles. Artists have always known this. Salvador Dali didn't just paint dreams, he courted them, napping with a key in hand so its clatter would wake him at the edge of sleep, where visions are most vivid. His melting clocks and floating elephants weren't arbitrary. They were snapshots of a reality where gravity and time obeyed different rules, much like quantum particles that exist in multiple states until observed. The surrealists called this the marvelous, a realm where the tapestry's hidden knots and seams become visible. Even filmmakers like David Lynch treat dreams as portals. Twin Peaks' Black Lodge isn't just a plot device, it's a rendering of the universe's backstage where all stories intertwine. But here's the science that blurs the line between metaphor and mechanism. During REM sleep, the brain's default mode network, the system responsible for our sense of self, quietens, while the hippocampus replays the day's events in fast forward. This isn't random shuffling. Studies show rats navigating mazes in their sleep, their neurons firing in the same sequence as when they were awake, as if rehearsing or refining. Could this be the brain's way of weaving itself into the cosmic web, aligning personal memories with broader patterns? The Aboriginal concept of the dream time offers a startling parallel. It's not just a creation myth, but a living dimension where past, present, and future exist simultaneously, a realm accessed through dreams and ritual. Quantum physicists wrestle with similar ideas when they speak of the block universe, where time is a frozen landscape and our linear experience is an illusion. Indigenous wisdom and cutting-edge science might use different vocabularies, but both suggest dreams are less escapes than intersections, where individual consciousness briefly merges with the tapestry's grand design. So tonight, when you close your eyes, consider this. Your dreams might not be yours alone. That recurring image of a door you can't open, or a voice calling from underwater. What if it's the universe testing a new stitch in the fabric, or a distant thread plucked by someone else's wonder? Sleep isn't an off switch. It's the Loom's quiet hum weaving you deeper into the story. Beneath the ocean's surface, coral reefs pulse with a rhythm that would feel familiar to anyone who's wandered a city at night. Neon-colored fish dart through canyons of branching coral like commuters weaving through skyscrapers, while cleaner shrimp set up stations where larger fish queue up for grooming, a marine version of a subway rush hour. But the real magic happens when the sun sets. Corals, those tiny colonial animals, engage in synchronized spawning, releasing eggs and sperm into the water in such precise unison that scientists compare it to a metropolis coordinating its streetlights. All this without a central brain, without blueprints, just an ancient, wordless agreement written into their DNA. It's as if the reef remembers it's part of something larger, each polyp a single stitch in a living tapestry that spans the sea. Meanwhile, on land, forests hum with conversations we're only beginning to decode. Beneath the soil, fungal threads called mycelium weave through roots like subterranean fiber optics, linking trees in a network biologists Suze and Simard dubbed the Wood Wide Web. When a Douglas fir is attacked by beetles, it sends chemical warnings through these fungal pathways, alerting neighboring pines to bolster their defenses. Elder trees, their roots thick with decades of connections, act as hubs distributing nutrients to seedlings struggling in the shade, almost like pensioners passing down wisdom. Some studies suggest these networks even operate with a form of memory, recalling past droughts or infestations to better prepare for future threats. What we call a forest isn't just a collection of trees. It's a synaptic web pulsing with signals as intricate as the neural pathways in your brain. The parallels run deeper than metaphor. Slime molds, those gelatinous, single-celled organisms, can solve mazes to find food, then retract their tendrils into the most efficient pathways. When researchers placed oat flakes in the pattern of Tokyo's rail system, the slime mold reconfigured itself into a near-identical map of the city's subway lines. No engineer, no blueprint, just billions of years of evolutionary problem-solving. Even the human brain's connectivity mirrors the cosmic web of galaxies, with neurons clustering and branching in patterns that eerily resemble the universe's large-scale structure. It's as if nature has a favorite template for complexity, one it uses whether building a thinking organ or a galaxy cluster. Indigenous cultures have always sensed this kinship. The Yoruba people of West Africa describe the world as a great market where all beings trade stories and sustenance. Maori traditions speak of Wakapapa, a genealogy connecting rocks, rivers, and people in one unbroken chain. Modern ecologists now quantify these intuitions, measuring how mycorrhizal networks redistribute carbon between species. Birch trees feeding fir saplings in winter, firs returning the favor in summer, a silent economy older than currency. So what does this mean for our place in the cosmos? When a whale's song carries hundreds of miles through the ocean, or when a fungal spore hitches a ride on the wind to colonize a new continent, they're not just acting as individuals. They're nodes in a planetary nervous system, threads in a tapestry that might stretch far beyond Earth. Astronomers searching for life on other worlds now look for biosignatures, chemical imbalances in atmospheres that hint at collective activity. Maybe we'll one day find a forest on Titan, its methane rivers whispering through fungal networks, or a coral-like colony thriving in Europa's icy seas. The universe might not just contain life, it might think in ecosystems. Do you remember the Berenstain Bears, or was it Berenstein? For millions of people, the answer feels viscerally wrong, like a glitch in the Matrix. The Mandela effect, named after those who vividly recall Nelson Mandela dying in prison he didn't, is more than just faulty memory. It's a phenomenon where large groups share identical, detailed recollections that never happened. From Darth Vader's "Luke, I am your father," he never says "Luke" to the Monopoly man's monocle, which doesn't exist. These aren't just trivial mistakes, they feel like evidence that reality itself is being subtly rewritten, and some of us are catching the edits. Quantum physics offers a spine-tingling explanation. The many worlds interpretation suggests every decision spawns parallel universes, infinite versions of reality where the Berenstain Bears are spelled every possible way. Occasionally, the theory goes, these timelines might brush against each other, letting memories leak across the divide. It's like living in one edition of a book while dreaming passages from another. Even more radical is the holographic principle, which posits our 3D world is a projection from a 2D surface. If that surface gets updated, could it alter our collective past like a cosmic retcon? But the mind plays tricks too. Cognitive scientists point to confabulation, the brain's habit of filling gaps with plausible fabrications. When we hear Berenstain, our neurons auto-correct to the more familiar Stein ending, reinforcing the false memory each time it's recalled. Social contagion amplifies this. Misinformation spreads faster than truth, especially in the digital age. Yet that doesn't explain why so many recall the same specific details, like the fruit of the Loom logo's non-existent cornucopia. Ancient cultures had their own versions of this mystery. Hindu texts speak of the Maya, the illusion that reality is solid and unchanging. Indigenous Australians describe the dream time as a malleable layer beneath daily life, where stories can reshape the physical world. Even Philip K. Dick, after a bizarre episode in 1974, claimed he'd glimpsed alternate timelines overlapping with ours, leaving residues in art and memory. Perhaps the truth lies in between. The universe isn't a static painting but a living canvas, its brushstrokes still wet. Every observation, every measurement might nudge reality slightly, not enough to break the laws of physics, but enough to leave phantom impressions in our mind. When thousands swear they saw Pikachu's tail tipped black, it wasn't, or Sinbad starred in a genie movie called Shazam, he didn't, they're not just misremembering. They're sensing the tapestry's loose threads, the places where the weave might still be adjusting. So the next time someone insists it's always been that way, pause. The universe's story isn't set in stone. It's written in sand, reshaped by every wave of observation. And sometimes, if you squint, you can see the tide coming in. A perfect circle drawn in the sand and the orbit of planets share a secret geometry isn't just a human invention, but perhaps the universe's mother tongue. The flower of life, an ancient symbol found in Egyptian temples and Chinese pottery, isn't merely decorative. Its overlapping circles mirror the way soap bubbles cluster or atoms arrange in crystals, as if civilizations separated by millennia and continents all glimpsed the same underlying code. Even the Sri Yantra, a sacred Hindu diagram of interlocking triangles, encodes mathematical ratios that match the vibrational frequencies of atoms. It's as if these patterns aren't just symbols, but maps, a way to navigate the hidden scaffolding of reality itself. Plato suspected this centuries ago when he proposed the 5 Platonic solids tetrahedron, cube, octahedron, dodecahedron, and icosahedron as the building blocks of existence. He believed fire was made of tetrahedrons, earth of cubes, and water of icosahedrons, their sharp or flowing shapes dictating how each element behaved. Modern science laughs at the specifics but not the principle. Carbon atoms form tetrahedrons in diamonds, their rigid geometry making them the hardest known natural material. Water molecules, with their bent icosahedral arrangements, create the unique properties that let life exist. Even viruses, like the common cold, often shape themselves into near-perfect icosahedrons, their geometry a weapon honed by evolution. The Great Pyramid of Giza whispers the same truth. Its base-to-height ratio approximates pi, while its alignment with true north is more precise than the Royal Observatory in Greenwich. Medieval masons encoded the golden ratio into cathedrals like Notre Dame, their arches and spires humming with proportions that resonate in seashells and spiral galaxies. But here's the mystery. Did these builders discover these patterns in nature and replicate them? Or did they tap into something deeper, a geometric layer that shapes nature itself? Quantum physics edges toward the latter. At the smallest scales, particles don't just bump around randomly, they arrange into geometric lattices, their positions dictated by wave functions that solve equations first sketched by Pythagoras. Crystallography reveals how snowflakes branch in 6-fold symmetry, not because of some mystical rule, but because water molecules lock into hexagonal grids as they freeze. Even the vacuum of space isn't empty. Quantum foam theorizes it's a seething mesh of geometric fluctuations, tiny triangles and curves popping in and out of existence. Artists have always chased these ghosts. Buckminster Fuller's geodesic domes mirror carbon-60 molecules, their spherical strength born from triangular grids. Kandinsky's abstract paintings pulse with shapes he claimed vibrated at spiritual frequencies. Islamic mosaics, forbidden from depicting living forms, turned geometry into a divine language, their infinite tessellations a meditation on the eternal. So is sacred geometry just humanity projecting order onto chaos? Or is chaos itself an illusion, a veil over a realm where numbers and shapes are the truest reality? When a star explodes, its debris forms shock waves in perfect spirals. When a nautilus grows, its shell expands in a logarithmic curve. From the spin of electrons to the clustering of galaxy superstructures, the universe seems to be solving a geometric puzzle we're only beginning to trace. The compass and straightedge might be more than tools, they could be translators, helping us read the cosmic blueprint hidden in plain sight. Astrology maps the sky like a storyboard, each planet cast in a role: Mars as the warrior, Venus the lover, Saturn the stern teacher. For thousands of years, civilizations from Babylon to the Maya didn't just track celestial movements. They listened for their dialogue, interpreting conjunctions and retrogrades as plot twists in an epic where human lives were subplots. When Shakespeare wrote King Lear, he didn't just mention eclipses as decoration. He wove them into the narrative as omens, mirroring the king's unraveling mind with these late eclipses in the sun and moon. To the ancients, the heavens weren't a clockwork mechanism but a stage, and every alignment was a scene loaded with meaning. Modern science, of course, scoffs at the idea that Jupiter's position at your birth could shape your charisma. Astrophysicists point out that the gravitational pull of a delivery room doctor outweighs any distant planet's influence. Yet here's the paradox: even as astronomy divorced itself from astrology centuries ago, the metaphors stuck. Freud might have dismissed astrology as childish, but Jung kept a natal chart for his patients, calling it a useful map of the psyche. Artists from Frida Kahlo to David Bowie leaned into their zodiac signs not as fate, but as archetypes, tools to amplify their creative identities. Bowie's alter ego Ziggy Stardust didn't just reference the stars, he embodied them, a cosmic rock god spun from astrological glamour. The real magic of astrology might lie not in its accuracy, but in its narrative power. Think of the night sky as the world's oldest Rorschach test. When two people see the same constellation, one spotting a hunter, the other a plow, they're not arguing over facts. They're revealing how humans hunger for stories, especially ones that make us feel connected to something vast. A study in Nature Human Behavior found that people rate vague personality descriptions as uncannily accurate when told they're tailored to their birth chart, a phenomenon called the Barnum effect. But what if that's not delusion? What if it's proof that we're wired to find patterns, even in randomness, because meaning-making is survival? Consider the Voyager Golden Record, humanity's mixtape for aliens. Alongside equations and DNA blueprints, we included Bach's Brandenburg Concerto and Chuck Berry's Johnny B. Good. Not because extraterrestrials would understand rock and roll, but because music, like astrology, is a language of connection. When a poet writes, "Mercury is in retrograde," to explain a week of missed emails and traffic jams, they're not diagnosing cosmic interference. They're framing chaos as a story with rhythm, one where planets stand in for the forces we can't control. The irony, astrology's greatest failures might be its most profound truths. In the 1600s, Kepler, a founding father of astronomy, cast horoscopes for patrons to fund his research. He privately called it the foolish little daughter of science, yet admitted her mother astronomy couldn't survive without the income. Today, NASA Instagram captions playfully roast zodiac memes while the James Webb Telescope unveils black holes. The stars don't need to whisper for us to listen. We've been writing their scripts all along, turning gravitational dances into love stories and lifelines. Whether the cosmos cares is irrelevant. The story was never about the stars, it's about us reaching for them. Standing beneath a sky ablaze with stars or gazing at Hubble's deep field images of galaxies, something primal stirs in us, a tingling at the base of the skull, a breath caught in the chest. This isn't just admiration, it's awe, a neurological reset button that scientists now believe rewires how we perceive reality. Brain scans reveal that during moments of awe, the default mode network, the part of our brain obsessed with self-narration and ego, quiets dramatically. It's as if the universe flips a switch, silencing the mental chatter that separates me from everything else. In that silence, something extraordinary happens. Time dilates. A study at Stanford found that participants who watched awe-inspiring nature videos estimated time as passing more slowly afterward, as if wonders stretched the fabric of their internal clocks. But aw's magic runs deeper than altered perception. When researchers at UC Berkeley measured cytokine levels, markers of inflammation in people after awe-filled experiences, they discovered something startling. Those who reported feeling wonder had significantly lower levels of these stress-related proteins, as if their bodies were physically responding to vastness by dialing down turmoil. Indigenous cultures have known this for millennia. The Navajo concept of Hojo, often translated as walking in beauty, describes a state of harmony achieved by immersing oneself in nature's grandeur. Modern neuroscience simply confirms what rituals like vision quests or sunrise ceremonies have long practiced. Awe isn't just an emotion, it's medicine. Consider the overview effect reported by astronauts who see Earth from space. Their descriptions aren't just about the view, they speak of sudden, visceral realizations of interconnectedness. "You don't see borders from up here," astronaut Ron Garan reflected. "Just this fragile, glowing organism." MRI studies of astronauts' brains post-mission show lasting changes in regions linked to empathy and spatial awareness, as if cosmic perspective etches itself into neural pathways. Artists mimic this shift deliberately. Olafur Eliasson's Weather Project, a sun-like installation at London's Tate Modern, bathed visitors in artificial golden light, provoking the same wordless wonder as a desert sunset. Participants didn't just admire it, they lingered, laughed, even wept, their behavior mirroring studies where awe increases generosity and social bonding. So why does the universe bother stunning us into silence? Evolutionary psychologists propose that awe evolved as a survival mechanism, a way to swiftly reorient priorities in the face of things far larger than ourselves. A lightning storm or prowling predator would trigger this state, sharpening focus and encouraging communal response. But in our modern world, awe's true gift might be its ability to dissolve the illusion of separation. When you stand before a canyon so vast it swallows sound, or when a symphony's crescendo lifts you out of your seat, the boundaries between you and the world soften. The Portuguese have a word for this, saudade, a longing for something you're already part of. Perhaps that's the cosmos's quiet message every time it takes our breath away. The same atoms that forged supernovas spark in your neurons as you marvel at them. The same mathematical rhythms that spin galaxies also govern the spiral of your inner ear. Awe doesn't just make time feel expansive, it reminds us we're not observers of the universe, but participants. Every shiver down your spine at the sight of the Milky Way is the tapestry whispering back, "You're how I know myself." Borges' Library of Babel is a labyrinth of endless hexagonal rooms, each lined with identical books containing every possible combination of letters. Somewhere in that infinite archive, there's a volume that perfectly predicts your life, another that spells out the cure for cancer in gibberish, and countless more filled with nothing but senseless noise. The library isn't just a thought experiment, it's a mirror. If the universe is truly infinite, then every possible configuration of matter, every version of you reading these words in a slightly different tone, must exist somewhere in the cosmic stacks. Physicist Max Tegmark takes this idea to its dizzying extreme with his mathematical universe hypothesis, suggesting that every structure mathematically possible is physically real somewhere. Not just parallel Earths, but worlds where gravity repels, time flows backward, or consciousness emerges from swirling plasma. Consider the humble deck of cards. Shuffle it thoroughly, and the order you create has likely never existed before in human history. Yet in an infinite cosmos, every possible shuffle, every meaningless jumble, every perfect sequence must recur endlessly. This isn't just probability, it's a radical reimagining of existence itself. Indigenous Australian cultures speak of the Dreamtime as a dimension where all stories are equally real, where the past and future coexist like pages in a book. Borges, writing decades before multiverse theory entered mainstream physics, seemed to intuit this. His library has no center, no index, no librarian, just the overwhelming weight of all possible knowledge, most of it useless, waiting for someone to stumble upon meaning. The eerie part, science is catching up. Quantum mechanics suggests particles exist in superpositions until observed, as if reality hesitates between possibilities. The many worlds interpretation argues that each observation splits the universe, spawning new branches where every outcome plays out. String theory's landscape of possible universes, each with different physical constants, numbers around 10 to the 500, a figure so vast it makes Borges' library seem modest. Astronomers even hunt for evidence of collisions between universes in the cosmic microwave background, looking for bruises where our bubble universe might have bumped against another. Yet Borges' genius lies in the despair tucked between his library's shelves. If every truth exists, then truth loses value. If every story is written, does any story matter? Theologians wrestle with this too. If infinite versions of you make every choice, is free will an illusion? Buddhist philosophy offers a counterpoint. Perhaps the point isn't to find the right book, but to recognize that the library itself is the illusion. The Tibetan Book of the Dead describes reality as a bardo, a transitional state where perception projects the world into being. In that light, the multiverse isn't a cold archive, but a hall of mirrors reflecting the observer's endless faces. Artists and gamers have turned this idea into playgrounds. Procedurally generated worlds like No Man's Sky use algorithms to create quintillions of unique planets, ensuring no player sees them all. Novelists like David Mitchell weave narratives where characters in different eras glimpse the same cosmic pattern, suggesting the library has a hidden catalog after all. Even Wikipedia, with its ever-expanding web of links and forks, mirrors Borges' vision, a finite but unfathomably vast approximation of the whole. So are we solitary readers lost in the stacks, or sentences in a story too large to comprehend? The library's terror and beauty lie in the same truth. It contains not just all answers but all questions. Every time you wonder, what if, somewhere, a version of you is living it? The cosmos might not be a library, but it's certainly writing, and we're not just the audience, we're the ink. Eclipses don't just darken the sky, they rewrite the script of human attention. In ancient China, people banged drums to scare away the dragon devouring the sun. The Vikings believed wolves were chasing the celestial lights, while the Warlpiri people of Australia saw eclipses as spirits demanding silence, a moment so sacred even children stopped crying. These weren't just superstitions, they were stories etched into the collective memory, turning celestial mechanics into mythic theater. Today, the drums have been replaced by Instagram posts and live streams, but the impulse remains the same. When the moon's shadow races across the Earth at over 1,000 miles per hour, highways jam with parked cars, and strangers pass around eclipse glasses like sacred objects. For those few minutes, the universe doesn't just command our gaze, it sinks our breath. Science explains the mechanics. The moon's orbit tilts just right to occasionally block the sun, casting a shadow that's never wider than 269 miles. But numbers can't capture the weight of that darkness. In 1919, Arthur Eddington photographed stars bending around the eclipsed sun, proving Einstein's theory of relativity. The data was groundbreaking, but what lingered in public memory was the image, the sun's corona flaring like a crown, as if the cosmos itself was staging a coronation. Artists have tried to bottle this awe for centuries. In the Mahabharata, an eclipse heralds the great battle of Kurukshetra, while Norse poets describe the sky wolves Skurll and Hati finally catching their prey, plunging the world into twilight. Even George Harrison's Here Comes the Sun takes on new meaning when played during totality, that moment when day flips to night and back again, like a cosmic light switch. Modern eclipse chasers spend fortunes chasing shadows across continents, but the real magic isn't in the spectacle alone, it's in the shared silence. In 2017, as totality swept across America, traffic stalled on interstates as drivers pulled over, weeping. Wedding vows were exchanged under the diamond ring effect. One couple in Oregon named their child Eclipse. These rituals, ancient and new, reveal something primal. We don't just watch the sky, we converse with it. The Maya calculated eclipses down to the minute without telescopes, their observatories doubling as stages for ceremonies where kings reforged their divine mandate. Today, NASA live streams reach millions, yet the experience remains intimate. When the last sliver of sun vanishes, temperature drops, birds roost, and the horizon glows like sunset in every direction. For those brief, uncanny minutes, the universe reminds us it's not just a void, it's a performer. Perhaps that's why eclipses transcend culture and century. They're the rare phenomenon that resists cynicism. No one checks their phone during totality. No one argues about politics when the sky goes black at noon. In a world fractured by algorithms and echo chambers, the moon and sun still pull us into the same story, if only for a moment. The ancient Greeks called eclipses eklapsis, abandonment. But what feels like abandonment is really an invitation to look up together and remember that all our dramas, all our divisions, are just subplots in a grander narrative. The shadow passes, the light returns, and for a heartbeat, the whole human chorus gasps in unison. A missed train in Munich, 1897. An ordinary delay, except for the passenger pacing the platform, a young Adolf Hitler, rejected from art school and seething with resentment. Had that train arrived on time, would he have boarded it instead of lingering in the city's political underbelly, where anti-Semitic pamphlets stoked his fury? Historians call these moments contingencies, the tiny hinges upon which history swings. They're the universe's rough drafts, scribbled over and revised by chance. The assassination of Archduke Franz Ferdinand only sparked World War I because his driver took a wrong turn onto a street where Gavrilo Princip happened to be buying a sandwich. The Cuban Missile Crisis teetered on a Soviet submarine officer refusing to launch a nuclear torpedo after losing contact with Moscow. These aren't just footnotes, they're proof that chaos weaves the fabric of our past as surely as any grand design. Novelists have long been obsessed with these fractures in time's tapestry. Stephen King's 11/22/63 follows a man who travels back to prevent JFK's assassination, only to discover the universe fighting his edits like a stubborn author clinging to a plotline. The lesson isn't just about the fragility of history, it's about the weight of small gestures. A spilled cup of coffee delays a shooter's aim. A child's laughter distracts a driver who then misses a fatal collision. In King's world, as in ours, the mundane and the monumental are threads in the same weave. Historians grapple with this through counterfactuals, the what-if scenarios that haunt archives. What if Alexander the Great hadn't died at 32? Would Rome have risen? What if Marie Curie had chosen botany over radioactivity? Science fiction writer Philip K. Dick took this further, suggesting alternate timelines aren't hypothetical but real, bleeding into our world through déjà vu and synchronicity. Indigenous Australian cultures would agree. Their Dreamtime stories describe history as a living network where every decision branches into new songlines. Yet chaos doesn't mean randomness. When a butterfly's wings stir a hurricane, it's not magic, it's non-linear dynamics, the hidden order within apparent disorder. The same math that predicts weather patterns also explains why Rosa Parks' refusal to move sparked a revolution, or how a lone protester standing before tanks in Tiananmen Square became a global icon. The universe doesn't play dice, as Einstein griped. It plays chess, where a pawn's advance can topple kings. So is history written in ink or pencil. The answer might lie in quantum physics' many worlds interpretation, where every choice spawns a new universe. In one timeline, that Munich train arrives on time, and Hitler fades into obscurity as a mediocre landscape painter. In another, the Library of Alexandria never burns, and humanity leaps ahead by millennia. But in this timeline, all we have are the echoes of roads not taken, the whispers of what might have been, tangled in what is. The tapestry isn't just frayed at the edges, it's unraveling and reweaving itself with every breath we